Okay, today we're going to talk about graphing linear equations. So the first thing we have to talk about is an equation in two variables. Okay, and an example of that would be something like 2x plus 5y equals 8, right? There's two variables and it's an equation. And a solution of an equation in two variables, x and y, is an ordered pair, x, y, that produces a true statement when the value of x and y are substituted into the equation. So for example, where it just says down here, which ordered pair is the solution of 3x minus y is 7. So we're going to plug in, remember this is x and this is y. So we're going to plug those in and see if it makes it true. So 3 times x minus 5, because that's y, equals 7. So 3 times 3 is 9. 9 minus 5 is 7. Does 4 equal 7? No. So this is not a solution. But what if we plug in x and y, 1 and negative 4? So 3 times 1 minus negative 4, because you're subtracting y, and y is negative 4. So that becomes 3 plus positive 4 equals 7. So is that a solution? Yes. Okay, let's try the others and see if they work as well. So 3 times 5 minus negative 3. So 15 minus negative 3 is 18. Does that equal 7? No. And then this one right here. So 3 times negative 1 minus negative 2, does that equal 7? Negative 3 plus 2 does not equal 7, so this one is not a solution. Okay, and then it says tell whether 4 negative a half is a solution of 3x minus y equals 7. So it's the same equation, okay, different ordered pair. So we're going to do 3 times 4 minus negative a half. 3 times 4 is 12 plus positive a half. Does that equal 7? No. Okay, the next paragraph says the graph of an equation is in two variables is the set of points in a coordinate plane that represent all solutions of the equation. If the variables in an equation represent real numbers, one way to graph the equation is to make a table of values, plot enough points to recognize a pattern, and then connect the points. When making a table of values, choose convenient values of x that include negative values, 0, and positive values. Okay, and then it says graph the equation, and then I wrote down the steps. So step number 1 is we want this solved for y. Okay, so this is why when we spent all that time talking about solving equations for different variables last chapter, this was why we were doing that. Okay, so if I want y by itself, what am I going to do with that 2x? You're going to add 2x to both sides, right? Because I want this to cancel. So I'm going to have y equals 2x plus 3. 2x plus 3. Okay, so I always like to pick 0 because that's an easy one. So if I put a 0 in here, 2 times 0 is 0, plus 3 is 3. So I have the point 0, 3. Okay, then let's say I pick negative 2. 2 times negative 2 is negative 4, plus 3 is negative 1. So I have the point negative 2, negative 1. Well, what if I picked the point, let's do 3, positive 3. 2 times positive 3 is 6. 6 plus 3 is 9. So I have the point 3 all the way up here to 9. Okay, let's pick another negative. Let's pick negative 5. 2 times negative 5 is negative 10, plus 3 is negative 7. So negative 5, negative 1, 2, 3, 4, 5, 6, 7. Okay, and then one more. I'm just going to pick 1. 2 times 1 is 2, plus 3 is 5. So I have the point 1, 5. Okay, and if you look, they formed a line, right? These are linear. I'm going to connect them with the line, and I'm done. Okay, and you guys can all pick different points, right? We're not all going to pick the same points every time. So let's just say that you had picked -1. Okay, 2 times -1 is -2. -2 plus 3 is +1. So look, -1, +1. That point is still on our line, right? So even if we all picked different x values, we should still end up with the exact same line. Okay, look at the next page, or flip your page over. So it says a linear equation is an equation whose graph is a line such as the equation in the example above or before. The standard form of a linear equation is ax plus by equals c, where a, b, and c are real numbers and a and b are not both 0. Okay, you could have one of them be 0, right? A could be 0 or b could be 0, but they can't both be 0. So it says, let's consider what happens when a equals 0 or when b equals 0. Okay, so when the equation, when we have ax plus by equals c, if a is 0, what's 0 times x? 0, right? So it's just by equals c. And so if we're trying to solve this for y, if we want to get y by itself, what do I need to do? Divide both sides by b. So y would equal c over b. Okay, if you're like, where did she get that? Let's come over here. So by equals c, right? Because a was 0, so ax went away. So now if I'm trying to get y by itself, I'm going to divide both sides by b. So y equals c over b. Okay, well, let's talk about when b is 0, right? If this went away, because this is 0y, so that's gone, then we're left with ax equals c. Okay, and if I'm trying to solve this for x, I'm going to divide both sides by a, c over a. Okay, so let's talk about it, what this means. Okay, so it says graph y equals 2. So let's do that first. Okay, where is y equal to 2? Right here. Okay, so let's think about points where y would equal 2. You could have 0, 2. You could have 4, 2. You could have -5, 2. Right? It doesn't matter what x is, the y value is 2. It's this line right here. Okay, and let's talk about the x equals -1. So this right here is where x is -1. So let's list out some points that have an x value of -1. Okay, that would be like -1, 0. -1, 5. That could be -1, -2. Okay, any point that has an x value of -1. So the graph of y equals a number is a horizontal line. The graph of x equals is a line, a vertical line, sorry. Questions on that? Okay, so let's look down. And it says graph the following equations. So we have y equals 3x, or y plus 3x equals -2. So I'm going to go ahead and I'm going to solve this for y. Okay, so that's going to give me y equals, I'm going to move that 3x over here, -3x minus 2. So what I can do is I can go ahead and I can find values. I can make a little chart, okay? And so what happens if I put in a 0 for x? -3 times 0 is 0. 0 minus 2 is negative 2. What if I put in a negative 1? Negative 3 times negative 1 is positive 3. 3 minus 2 is 1. So negative 1, positive 1. What if I put in the value of positive 2? Okay, if I put a 2, negative 3, actually that's going to be too big. Let's do positive 1. Negative 3 times positive 1 is negative 3, minus 2 is negative 5. 1, negative 5. And that's our line. Let's talk about when y equals 2.5. So up here, I know if it's just y equals a number, that's going to be a horizontal line. So here's where y is 2.5, in between 2 and 3, and it's horizontal. Okay, when it's just x equals negative 1, 2, 3, 4, I know it's going to be a vertical line, like that. Okay, and then there's one more page. It says, graph the function y equals negative 1/2 x plus 4 with the domain of x is greater than or equal to 0. Then identify the range of a function. Okay, so let's go ahead and make our table here. So we have x, and then we have negative 1/2 x plus 4, and then we have y. Okay, so it's telling me that the domain has to be greater than or equal to 0. So that means it could be 0, it could be 2, it could be 4, right? Anything that's greater than or equal to 0. So let's look at it. I'll show you why I picked evens. I picked evens because if I have to take a half of a number, it's going to be way easier to take half of an even number. So negative 1/2 times 0 is 0, plus 4 is 4. So 0, 4. Okay, well, what if I do negative 1/2 times 2? What's negative 1/2 times 2? Negative 1 plus 4 is 3. What if I did half of 4? And it's negative. That's negative 2 plus 4 is 2. Okay, and you don't have to pick evens, right? I could have picked the number 5. Negative 1/2 times 5 is negative 2.5 plus 4 is 1.5. So look, here's 5, 1.5. Those are all in a row. Oh, and then the last thing it says is to identify, let me shut my blinds. Whoops. Okay, the last thing it says that we have to do is identify the range. So let's look at the y values. The ranges are all what? What's the biggest range? 4, right? It can never go above here. Actually, I shouldn't have even done that, right? It can start here and go this way because the domain has to be bigger than 0. We can't have anything less than or equal to 0 or less than 0. So the y values all have to be less than or equal to 4. That's going to be my range. Okay, the x values all have to be greater than 0, which means the y values all have to be less than or equal to 4. Okay, it says graph the function y equals negative 3x plus 1 with domain of x is less than or equal to 0. Okay, so we have x, negative 3x plus 1, and then y. So this time, it says that the domain is less than or equal to 0. So 0, negative 1, negative 2, negative 3. Okay, so let's see what happens when I plug in 0. Negative 3 times 0 is 0, plus 1 is 1. So I get 0, 1. When I plug in negative 1, negative 3 times negative 1 is 3, plus 1 is 4. So negative 1, 1, 2, 3, 4. Okay, well, what if I plug in negative 2? Negative 3 times negative 2 is 6. 6 plus 1 is 7, right? So that's going to be way off here. Okay, so it's going to look like this. So if I have to make or define what the range is, okay, what are my ranges? My y's all have to be what? Greater than or equal to 1. Okay, and then this last part. It says the distance d in miles that a runner travels is given by the function d equals 6t, where t is the time in hours spent running. The runner plans to go for a 1.5 hour run. Graph the function and identify its domain and range. Okay, so let's do, so it's going to be t, that's our input, and then the distance equals 6 times t, right? And then we have the distance. Okay, so if they're running for half an hour, right, then we're going to do 6 times half an hour. They will have run 3 miles or whatever it is. Well, what if they run for a whole hour? 6 times 1 is 6. Well, what if they run for 1.5? 6 times 1.5 is 9. Okay, so over here, this is just like a stock image that I got. I'm going to label this as 0.5, 1, and 1.5, and that's t. Okay, in hours. And then this going up the side, I'm going to go by 3s. I'm going to make it real easy. 3, 6, 9, 12, and this is t, not t, d, which is the miles. Okay, so when the runner ran half an hour, they had gone 3 miles. When the runner ran 1 hour, they had gone 6 miles. When the runner had run 1.5 hours, they had gone 9 miles. I could even say if they ran 0 hours, they had gone 0 miles. Right? So let's talk about the domain and the range. Okay, our x values, they have to be what? Greater than or equal to 0. Can a runner run negative time? No. So our inputs have to be anything that's greater than or equal to 0. And let's talk about the range. The y values have to be what? Greater than or equal to 0 as well, right? Because you can't have a negative distance. Okay, and then it says, what if the runner in the above example plans to run 12 miles? Graph the function and identify its domain and range. Okay, well, we can actually come up here. We've already done it, right? That's where 12 would be. Okay, so this is the same function, and the domain and the range will be the same thing.